Completing the square can be used to make a quadratic equation that is not a perfect square into a perfect square, which is useful for graphing because it'll be in vertex form, but also for solving a quadratic equation. So let's look at an example that is a perfect square, and then we'll talk about how to complete the square. So if I have x squared plus 2x plus 1 is equal to f of x, this is an example of a perfect square because when I factor this, I get x plus 2 times x plus 2. And these factors a number that's being multiplied, so I have two factors here, are identical. So this becomes x plus 2 squared is equal to f of x. This is a perfect square. An example of not a perfect square would be where I don't get the same factors. So x squared plus 2x minus 8 equals f of x. This becomes x plus 4 times x minus 2. These are not identical factors, so this is not a perfect square. So how do I complete the square? Well, first of all, you need to have your quadratic equation in standard form. Standard form is ax squared plus bx plus c is equal to f of x, or whatever it's equal to on this side. So there's one thing you need to make sure of, and that is that your a is equal to 1. If your a is not equal to 1, like it is in this problem here or this problem here, you cannot complete the square. The method will not work. So if it's not equal to 1 and you want to complete the square, you need to factor out some numbers that allow you to get this equal to 1. And we'll do an example of that. So how do you complete the square? Well, you're going to add in a number here that makes this a perfect square. You'll still have your plus c out here. And that number will be b divided by 2 squared. And you're just going to add that in over here. Now, if you add it in, you have to subtract it to make sure that you're not changing the problem. Or you can add it to the other side. Both are the same thing. So let's look at a real quick example. Let's say I have x squared minus 20x plus 49 equals negative 2. And I want to solve this by completing the square. So this is not a perfect square right now. So I know that my a is equal to a 1, which is good, so I can complete the square. I'm going to take my b, which is negative 20. I'm going to divide that by 2, which equals negative 10, and then I'm going to square that number, and that gets me 100. So that's the number that I'm going to be adding in right here, plus 100. I still have that plus 49. It doesn't go away. But because I added in 100, I now have to either subtract 100 or I can add 100 to this side. But you're doing one or the other, it's both the same thing. So I'm just going to do a minus 100 over here. This has now become a perfect square, and it is x minus 10 squared. So I still have that plus 49 and that negative 100. Plus 49 and negative 100 gets me negative 51 equals negative 2. I'm now going to add this 51 over to solve for x by isolating it, and I get x minus 10 squared is equal to positive 49. I'm going to square root both sides, and I get x minus 10 is equal to plus or minus square root of 49, which is 7. Now, it's plus or minus because it's a quadratic equation. The graph of a quadratic equation looks like this, and you can get two answers for the same y value, which is why you do a positive one and you do a negative one. So I have x minus 10 equals plus or minus 7. So x, if I add 10 to both sides, positive 7 plus 10 would get me 17. Negative 7 plus 10 would get me positive 3. Those are my two answers. So let's do another example of completing the square. What if I have 10x squared plus 20x minus 80 is equal to f of x. So in this problem, I'm not setting this equal to any number. I'm just saying that this is my function. So I'm not actually going to solve for x. I'm just going to complete the square and get this into vertex form. Vertex form is when you have x plus or minus some number squared plus or minus another number. So first thing I notice is that my a does not equal 1, but I want it to equal 1. I also notice that each number is a factor of 10. So I'm going to factor out 10. But I'm only going to do it from over here because I could do it from this too, but there's no point really because I know that's not going to be part of my perfect square. Just like up here, this plus 49 was not included anywhere in this perfect square. So I'm just going to factor out the 10 from the first two terms. And I get x squared plus 2x, and I still have that minus 80 is equal to f of x. So now I want to complete the square. I'm going to take half of my b, which is 2. 2 divided by 2 is equal to 1. I'm going to square that number, and I still get 1. So I'm going to add that in, x squared plus 2x plus 1. Now, I have changed the problem by adding in this 1. So I need to adjust for that, just like I did last time. But actually, I have not just added in 1. I have added in 10, because everything in here is being multiplied by 10. So by putting a plus 1 in here, I have added 10 to this side. So I now need to subtract 10 to balance that out. This has become a perfect square, which is x plus 1 squared. And I still have that 10 being multiplied. Negative 80 minus 90 minus 10 gets me negative 90. And this is now in vertex form. And I've completed the square. If this was equal to 0, then I would just solve just like I did last time. I would add 90 to both sides, divide by 10, square root both sides, and then subtract 1, and I would get x by itself. So let's do one more example of completing the square. Let's say I have x squared plus 4x plus 1 is equal to 0. Now in this problem, it is equal to 0, so I am going to solve this. If I were to factor this, I would need to multiply to 1 and add up to 4, but no numbers do that. I could use the quadratic equation. That is a valid technique. I would get the same exact answer, but let's do it with completing the square. So my coefficient of x squared, which is the a, does equal 1 here, so I can complete the square. I'm going to take my b, which is 4. I divide that by 2. I get 2. I'm now going to square that, and I get 4. So that's a number that I'm going to be adding in to make this a perfect square. Now because I added in a 4 over here, I'm either going to add in a 4 on this side, or I'm going to just subtract a 4 from over here. I'm just going to add a 4 onto this side. So this has become a perfect square. And it is x plus 2 quantity squared. And I still have that plus 1 over here and that 4 on the other side. I'm going to subtract 1 to solve for x, get it by itself, and I get x plus 2 squared is equal to positive 3. I'm now going to square root both sides, and I get x plus 2 is equal to plus or minus root 3. I'm going to leave this as root 3 instead of plugging it into a calculator. Putting it into a calculator will get you an approximation. I'm going to leave it as plus or minus root 3 so I can get an exact answer. Again, it's plus or minus because this is a quadratic, so you'll get 2 answers. It is possible that you do not get 2 answers when solving a quadratic equation. An example would be when you have a perfect square and that's all. There is nothing else in your problem. This right here we just factored gets me x plus 2 squared is equal to 0. The only thing that makes this 0 would be negative 2, and that's all. There's nothing else, so I would get 1 answer. But here there are other numbers like this plus 1, so it's not exactly a perfect square by itself. So x minus 2, or x plus 2, I'm going to subtract 2 from both sides, and I get x equals plus or minus root 3 minus 2. And those are my answers. Real quick to recap, your quadratic will be in the form of ax squared plus bx plus c is equal to f of x or equal to 0. You're going to make sure that your a is equal to 1, and if it is, you can complete the square. You're going to take your b, you're going to divide it by 2, and then you're going to square that. You're going to add it in, but then you have to add it into the other side or subtract it from this side to make sure that you haven't changed the problem.